I'm recording. All right, so I'm only on that board. This board stopped working. I'm sorry. Yeah. All right. So says given the point 3 comma 4. So 3 comma 4, 1, 2, 3, up 1, 2, 3, 4. We have a dot. Agree so far? We then have a slope of 2, so we're going to put it as 2 over 1. So from the red dot, we're going to go up 2, right 1. And connect the dots and draw in our line of best fit. Okay? So all we need to graph a line is 1 point and the slope. Okay? We need 1 point and a slope. All right, so this is called our point-slope form. Point-slope form is the most worldwide used form of linear equations. Unfortunately, we kind of got away from it when Texas Instruments came out with their graphing calculator because it only accepted it as y equals. But now if you ever use Desmos, it'll take care of it. All right, so we have a slope of 3. So that's our slope. We have a point here, and I'm going to call this x1 and y1. And this is on the second page. All right. Remember, when I was using point slope originally, when I pulled the point out originally, it is opposite. It's opposite when we plug it back in. So I'm going to plug the opposite of 7 in, so I'm going to have minus 7. The slope we said was negative 3. X minus, and it's minus minus 1. So minus minus 1 is plus 1. And that is our equation. Okay?
Making sure you're writing these notes, especially kids on the last test really struggled with this.
All right, so this is my slope on this one. So that's going to go in there. I'm going to call this x1 and y1. But remember, when I plug it back in, the slope will stay the same, but the point itself, it's not going to be minus 8. It's going to be plus 8. And the slope is 2/5. And then x minus 10. And this is my equation. Okay, it's a plus 8 because it was originally a negative 8, so it's going to be opposite value when we plug it in. Okay, we have this as our slope. This is our point. That's x1 and y1. When we plug them back in, the point back in, it becomes opposite value, so that becomes y plus 7. Notice it had been a minus 7 there. The 6 for the slope stays the same. And then x minus 3, because it was a positive 3, becomes negative 3. And that's all it is. So, so when you're doing these problems, let me just go to a thing. So slope, this is just a side note. Slope gets plugged in as is. The point gets plugged in using opposite values. So if it was positive, it plugs in to become negative. If it's negative, it plugs in to be positive. Okay? So this is just kind of a side note. A couple side notes to go with that. So we are creating the linear equations based on some information. All right, so write the equation with a slope of 1/2. So does the 1/2 get plugged in as is? Yep. So I'm going to plug it in just like this. And then I plug my point in, my x1 and y1. Those values become opposite. So the negative 3 plugs in to become plus 3. The 1/2 plugs in the positive 4 becomes negative 4. Now, we can make these look like this, okay? And we do that a couple of ways. I'm going to distribute 1/2 over the parentheses. Half times x is just half x. Half times negative 4 is negative 2. And then I want the y by itself, so I'm going to subtract 3 from both sides. So this is just a different form that we are using, but this is slope-intercept form. And this one is our point-slope form. Okay, it's just two different ways to write a linear equation. Okay, there's not one way that's more correct than the other. The point slope is more used worldwide than slope intercept, but that's all it comes down to it. Okay, so let's take a look at page 167. And let's try a couple of these. Let's go to number 6. So I know this is my point slope equation. Okay. This plugs in directly. These get plugged in as opposite value. So this becomes y minus 0 or y plus 0. Y minus 0 or y plus 0 is the same thing as just saying y. So I could just leave it like that. Or I could have written it like this. This means the exact same thing. In reality, what they would actually take both of these to be is they would make it look like this. And because you have parentheses, you know that this is point slope. Okay? Either of these answers is totally right as well. If you take it to this over here, you'll be fine. I'm looking at number 6 on. Oh, okay. Yeah, we went down to number 6. Okay. All right. Now, how would I do problem number 1? What does it say to do? Find the slope, right? So the slope equation's this. And a really good way to start this is label x1, y1, x2, y2, and plug those values into your slope equation. So y2 is 10, y1 is 3, there's a minus sign. X2 is 3, x1 is minus 6. So 10 minus 3 is 7. 3 minus 6 is negative 3. So that's my slope. Okay? So here's a big question. Here's a big question. Let's look at number 7. We're given 2 points, yes? We don't have the slope, agreed? Can I find the slope when given 2 points? Yeah. So I'm going to label it x1, y1, x2, y2. So my slope is going to be 6 minus 5, negative 4 minus minus 2, which is 6 minus 5, negative 4 plus 2, which is going to give me 1 over negative 2. That's my slope. Now, that slope is going to happen regardless. If I called this x2, y2, x1, y1, I'm still going to get the same slope. I mean, I might wind up with the negative on top versus the bottom. That's okay. So if I want to plug this into point slope, our slope goes in directly. Here comes a sneeze. Here it is. Oh, yeah. I feel blessed. Okay. Now, if I picked this point here and I plugged it in, I'm going to get y minus 5 equals negative 1/2 x plus 2. If I pick this point here, I'm going to get y minus 6 equals negative 1/2 x plus 4. Both of these answers are 100% correct. But I don't know about y'all, but y minus 5 equals negative 1/2 x plus 2 looks a little different than y minus 6 equals negative 1/2 x plus 4. Agree? They are the exact same linear equation. If I solved both of those for y, this is how it works. So that's as far as you can go, but I want to show you this. I'm going to distribute half over. Half of 2 is 1. Add 5, add 5. So I get y equals negative 1/2 x plus 4. If I did the same thing here, distribute, distribute. Add 6, add 6. Are those the same answer? Mm-hmm. So point slope appears that you had two very different answers, but your two very different answers actually yield to the exact same linear equation if you solve for y. Okay? So, should we give you the opportunity to try and figure some of these out? Yeah. So page 167, 168. We did, let's make sure we do them all. Now, if you took some of the notes, you know that we worked some of them out, right? Sweet.